Okay, as promised, let's get into solving. Now, to solve an inequality, it's extremely similar to solving an equation. There's only one time where it changes, and when that happens, I'll show you. But for right now, know that the way you solve an inequality is basically the same way you solve an equation. Let's look at the directions. They ask us to solve, graph, and then write the solution in interval notation. So look at problem 1. You see parentheses there? Do you remember what I mentioned in a previous lecture? Yeah, what did I mention? Get rid of the parentheses. Yeah, so what are we going to do first? Good, we're going to distribute. So I end up with 8x plus 4 is less than 4. Agreed? And now you got to get x by itself, so what are you going to do? Move the 4 over, so I end up with 8x less than 0. So be it. Some people think when they get a 0 there, it's like something, we got to do something completely different. No, 0 is a viable number. It's good. Cool? Okay, and now I got to get rid of the 8, which means you're going to have to, good, divide both sides by 8. Now again, for us visual people, some of us literally need to put this in here so we can see what this looks like. So if that's you, please do it. So I end up with x is less than 0, because 0 divided by 8 is 0. All right, now what do they want us to do after we solve? They'd like us to graph. So let's graph this. This is a solution. Let's graph it. What's the only number I care about? Yeah, all I care about is the 0. And x is a number, so I want numbers that are less than 0, which means that's to which side? Good, that's over here to the left. So all these numbers on the left are less than 0 all the way out to negative infinity. Agreed? What are you going to put on the 0? Good, open circle. And some of you are saying parentheses. I don't care which one you put, but put one. And some of you may want to get in the habit of a parenthesis or a bracket, because the next thing you're going to write is interval notation, and that will help you write the interval notation. So, knowing I'm going to write negative infinity first, what do you put around it? Parentheses. And the shading ends at the 0, and what are you going to put on the 0? Also a parenthesis. Good? Okay, let's look at number 2. So, no parentheses here. All I have is a straight to moving things over. So what's got to go first? The 7. So I get negative 2x is less than 2. And then what do you have to do? Yes, you have to divide by a negative 2. On both sides, agreed. Whoops. Now, just watch for a second, don't write anything down. So we know these negative 2's cancel, and on the left side remains an x. On the right side is a negative 1. Now, here's that one instance that is different from solving equations. So watch a second. I'm going to sidetrack you a moment, so let's look right here. Let's see. I'm just going to write this down. 4 is less than 5. Do you agree? Okay. If I multiply both sides by, say, a negative 2, then I end up with a negative 8 on the left and a negative 10 on the right. Agreed? Which one of these is larger? Negative 8 is larger than negative 10, isn't it? So notice what happened to the inequality sign. It flipped, didn't it? It was less than, but the numbers switched their values. What was the smaller number now became the larger number when you multiplied by a negative. And what was the larger number now became the smaller number when you multiplied by a negative. So the inequality sign flips. Now, division is the opposite of multiplication. So what happens for multiplication will always happen for division also, because multiplication and division are on that same playing field when you're talking about the order of operations. So when I multiply or divide by a negative number, my inequality sign is going to flip on me. So in this case, x has to be greater than negative 1. Got it? This is why. This example shows you why the inequality sign flips. Cool? Okay, so let's graph. Again, the only number I care about on this number line is a -1. You can put all the other numbers around it if you choose. And I'm looking for x's that are greater than -1. Yeah, those numbers are to the right, all the way out to infinity, aren't they? And what about the -1? Yeah, that's going to get a parenthesis because it's not equal to. Agreed? Okay, so what's your interval notation look like? Yep, parenthesis, -1 to infinity, close it. Now, let me show you something here. Because some of you see what happened by the example I just erased. You understand why the inequality sign is flipping. But some of you aren't completely convinced. Let's check this answer. Like, how do you check it? Well, take a number. Take a number between -1 and infinity. Yeah, 0. 0 is in between there, isn't it? Okay, so I want to check number 2. And I'm going to plug in a 0 for x. -2 times 0 is what? Sure, 0 plus 7. So this makes a true statement, doesn't it? It works, doesn't it? This works. Agreed? Okay. What if you did not flip your inequality sign? What if you forgot to flip your inequality sign and you left it as x less than -1? Give me a number less than -1. Good, -2. Let's just use -2. So we would have taken -2 times the -2 plus the 7 less than 9, right? -2 times -2, 4 plus 7 less than 9, 11 less than 9. Is that true? No, it's not. If you forgot to flip your inequality sign here, if you had left it as less than, and if you literally had checked your answer, you would have found that this solution set was wrong because it did not check. This doesn't check. This is another way to make certain that you have flipped the inequality sign appropriately. And the only time you flip it is when you multiply or divide by a negative number. Got it? Okay, I'll be right back with one more example.